Hello and welcome to this Meet Your Future session. In these sessions, we hear from people in different roles and you have the opportunity to ask them your questions about what they do and how they got to where they are. My name is Jamie Sloan and I'm your host today. I work at the Greater Manchester Combined Authority and it's my job to help young people find out more about the different careers and options that are available out there to them. One of the ways that you can do that is on the GMACS website, gmacs.co.uk, which has lots of information for young people who live in Greater Manchester. Today, though, as part of World Water Day, we are going to hear from Tom Eastgate, who is a principal consultant at Advision. Advision is a global consulting business, and they support their clients to find solutions to their energy, chemical, and resource needs. Tom is going to tell you a little bit about the company and about the different sorts of jobs that are involved in water. If you've got any questions, please put them in the chat and we will have time at the end to answer some of those. Right now, though, I'm delighted to hand over to Tom Eastgate.
Hi, everyone, and thank you very much for joining me today to talk to you a bit about careers in water and kind of and also how water is a highly important part of the energy transition, so which is us moving away from a carbon dependent energy source, moving towards carbon neutral. So I'll talk about that later. So today's World Water Day, so excellent opportunity to talk about careers in water, how to get into water, and also, as I said, how water's supporting the energy transition. First of all, just so you're all aware a little bit about me and how I've got to doing the work that I do now, working with water. So first of all, I, like many people, sort of did GCSEs, and during my GCSE stage, I've sort of found interest in biology, geography, and design technology, pursued those to A level. And the geography component was the area that I found very interesting at A levels, and then that led me on to undertaking a degree at University College London in environmental geoscience. And through that course, I was very privileged to be able to do some excellent dissertations. One studying a volcano in Mexico, which is a top photo there, and during that we looked at how the water chemistry from the volcano was be able to sort of provide a bit of a detail of what is happening under the water, with the chemistry changing dependent on the activity. Found that pretty fascinating. And then the year after that, we studied ice cores from Antarctica to look at climate change and how climate change over the millions of years had affected the sort of composition of the ice. To give us a bit of a history on what was going on at climate and how that affected that, so we could read more into what these cores were telling us about climate change. And that's so that was UCL, and by doing those two sort of master's topics, I then wanted to work within water to understand sort of not only because it's what it UCL has to sort of our how we need water, but also how it's sort of is critical to the environment and how water quality can affect sort of the environment, the ecosystems, and such like. So started doing working in UK sector, working in sort of consulting, looking at water quality in the UK, looking at in the aquifers and water resources. And then from that I undertook this MSc at Imperial College, which sort of really brought the hydrogeology part that I do now into sort of reality. And part of that is now looking at groundwater at sites across sort of mining sectors. So there's a picture there of a gold mine in northwest Africa, and also now working in geothermal sectors as well, which is part of the energy transition. We're getting quite a lot of that now, and groundwater is a very important part of that. but also run projects as well. Like water is obviously very important in sort of construction industry. So for dewatering, make sure you're able to build buildings with basements, but also water quality. So the London Olympics in 2012, worked on there for 2 years to understand how the water chemistry was being affected by all the cleanup of the site, to make sure that the work's been undertaken were actually giving some beneficial to the environment as well. So currently, so as mentioned, working on some geothermal projects. So we're working on a big project with the Science and Industry Museum in Manchester, looking at how to support their decarbonisation strategy, and part of that is to produce a ground source energy scheme to support sort of a low carbon running of the museum. And that's, as well as currently also working on an interesting project looking at lithium extraction as well from groundwater. So it's sort of which is also a very important part of the energy transition. So that's me. That's how I kind of got to where I am and some of the things that I do. But the waters in career, like careers in water, is it's sort of endless. I think if you think about all of everything we do, from drinking a glass of water during a meeting, or sort of construction, to hydropower, the water is sort of a critical part in it, which is when I was asked to do a talk on careers in water, it's sort of, where do you start? I think there's so water is sort of integral to so much of what we do, that actually there's lots and lots of opportunities to get into water, a career in water, and looking kind of from a practical sort of water resources, so water that we require for drinking. So there's a whole degree of chemistry in there, from processing that water so it's suitable for drinking, the wastewater side of things, and then cleaning it, making sure that it's meeting its standard. Then you've got civil engineering. So when you build, like for example, the Crossrail project in London, is a lot of the tunnels, or the majority of the tunnels, are underground. To build those tunnels, you quite often need to dewater and understand how the groundwater is fluctuating to ensure that the suitability of those tunnels is correct. And that sort of links into the hydrogeology. And that's my area of expertise. And hydro, water, and geologist is the rocks, so water within the rocks. And that sort of covers quite a large, pretty much most sectors that you can think of. So again, water supply for drinking, large sort of focus again on London. That's where I'm based. Just to the north of London, you've got the large chalk aquifers, so chalk material beneath the ground with water in it, and that's where a lot of the water that people drink comes from. So the hydrogeologists there sort of focused on that area. They look at how long that resource will be around, and make sure that it can have sustainable abstraction. Then hydrologists sort of look at the above ground water, water dams, water flow in rivers. Then you've got processes, hydroelectric, looking at flooding, drainage, water supply, mining. Again, mining is one of the areas I work in, and partly to going back to the slide beforehand, you saw that there was a large hole in the ground. A lot of the mining is open pit mining, and if you're going to dig a big hole, quite often you're going to cause water to run into that hole. So in this instance, you'd understand how quickly that water would flow in, and ways that you'd be able to mitigate against that by sort of putting in dewatering wells to control that flow and make sure it's a safe environment for the pit workers to be in. And you can also apply that theory also to underground mining. It was also in the oil and gas. There's a lot of water required for processing, and for ensuring that you're not impacting the environment. New energy, again, I sort of talk about this in a little bit when I focus on the sort of how water is important with the energy transition. I mentioned construction, infrastructure, but there's certainly a lot of careers, sort of options, really to get into the water world. And most of the time you find that we're always supporting other people. So if the hydrogeology, for example, in the pit, open pit sort of mine, you're normally talking with geotechnical engineers, the actual mining geologists as well, who are looking for the resource. So they want to have a open pit that targets the ore body, but also your geotechnical people will tell you what sort of slope they want to have the optimal sort of pit size. So you're always working quite alongside with many other industries, and I think that's what I specialists, and I think that's part of what I find fascinating about this, is no one project's the same, and you kind of also working with lots of other interesting areas of sort of engineering and science. I've talked about how I got into where I am with doing A-levels and then an undergraduate degree at UCL and a master's at Imperial, and that sort of specialist to get into the hydrogeology route. I think actually there's so many ways to get into a career in water that by no means is it necessary to go via the university route, and especially in the civil engineering and the construction industry, there's sort of so many options to join via apprenticeships these days. I think that's also a very good way to get involved with those, and also the sort of the direct employment as well. And I think really from what I sort of have seen from my sort of 15 years or so of working in this industry is actually what really makes this whole side of the working sort of sector interesting, is that so many people do come from such varied backgrounds through studying from a university, or sort of coming through a sort of apprenticeship program. It brings sort of so many useful and creative sort of minds together, that is such a benefit. That there are so many routes into the business that way. So I was going to quickly sort of put a stop here for questions. As Jamie mentioned at the beginning of the session, that we'll hold questions at the end, but sort of the idea was to sort of really open up now before I talk about how water's involved with the energy transition, to open up questions. But by all means, if you do have questions on routes into the water industry, or anything I've talked about, or any questions on what working is like and what I actually do, or anything like that, then put those questions in and we're happy to take those at the end. So I'll move on now to water and the energy transition. But first of all, I think it'd be good to clarify what the energy transition actually is. I'm sure a lot of people are sort of aware of the climate emergency and the need to reduce the amount of greenhouse gases that we emit into the atmosphere that's causing noticeable climate change in the UK and across the world. What the energy transition then is how we go about changing from a carbon high or greenhouse gas sort of high pollutant energy industry, so burning of conventional fuels such as gas and coal, which produce the greenhouse gases, and how we move away from that to a more sustainable green energy, and that's where the term energy transition is. As you can see those pictures there, some nice. First, the picture in the middle is a solar farm in the Middle East, which is quite innovative in that it sort of direct sunlight via a mirror onto multiple solar panels down on the surface. But you've also got solar, you've got wind and other green technologies. And so how's water involved with all of these new energies? I think there's some that are quite obvious. You've got hydroelectric dams, which have certainly not a new technology, but one we're becoming more dependent on. So water, obviously, that in that scenario is critical. You have large water dams. The hydrologists would need to provide input into how the water would flow, how quickly it will flow through into the dams, and what also the environmental impacts or the ecological impacts of such things might be. And so the hydrologists sort of working with multiple teams there, the environmental teams, the ecologists, geologists, many other sort of specialists in that to understand the impacts of the sort of putting in a large dam in a river. But that'd also be important on the whole flow and the channel, making sure that the civil engineering design is correct as well. Part of the more sort of similar to the project we're working in Manchester is there's a ground source scheme. So that's reliant on the groundwater, which is underneath the ground in rocks, having a constant temperature. So what you're doing with a ground source energy scheme is reliant on the underground temperatures. Quite often those temperatures are derived from the groundwater, which maintains a constant temperature throughout the year. And in the UK, it's sort of generally around 13, 14 degrees. So via mechanisms of sort of heat exchange, you can take some of that heat from that groundwater and then turn that into heating for the building, or even conversely use it for cooling by sort of extracting the coolness from the water. That way you're sort of providing almost free heating and cooling for buildings. One of the things that we found as a business is really important as well for especially the solar farms, which are becoming a huge business in the Middle East, is flood risk assessments, and that's making sure that where these solar locations are is actually they're not susceptible to flooding, given that they are ground-based units and have electricity coming from them. That's very important to make sure they're not going to be in an area that's subject to flooding. And in the Middle East, you have quite a large concern with flash flooding, where there's a sort of very rapid response to a sort of quick bit of rainfall. One of the more sort of modern, I guess, water issues with the green energy is where it's evolved for hydrogen, and I'm hopefully going to now share a video.
G'day. If you want to make green hydrogen, you need two key ingredients: renewable electricity, green electricity, and high purity water. The energy transition is all about making renewable electricity and other forms of green energy the main way that we power our world, so that we can eliminate the emission of fossil carbon dioxide. Many forms of renewable electricity vary in their availability either daily or seasonally. So to maintain a reliable energy supply system and achieve the energy transition that we need storage. And we need forms of energy that are storable and flexible. There are also some things that we cannot do with electricity on its own. For instance, ammonia fertilizer. It's a combination of nitrogen and hydrogen. And metal smelting. Many types of metal smelting use a reductant. Traditionally, that's been coal or coke, or petroleum carbon, but you can use hydrogen. Estimates are that the energy transition is going to require about 500 million tonnes per year of hydrogen. So to put it another way, this creek behind me here is flowing at about 1 cubic metre per second, maybe about 100,000 cubic metres a day. So we need about 150 of these creeks. Another way of comparing it is to think of all the water consumed by New York City. 150 tonnes a second would be enough water to supply 3 1/4 New York cities. It's a lot of water, and it has to be ultra pure. That's a big water supply problem, and it's a very big water treatment problem and a waste management problem. All of that are things that Worley has got a lot of experience in helping you with. So where will you get the water from? How will you treat it? How will you manage the waste? How much will the plant cost? Who will own it? Who will maintain it? How long will it last? Do you need permits for it? Are there any grants or government support? Do you need any help writing or preparing the grant applications? These are all things that Worley can help you with. Give us a call.
Thanks, and hopefully everyone managed to see that. Yeah, so put together by our Australian team, obviously, just kind of their hydrogen, the water need for hydrogen. So green hydrogen, just for clarification, is hydrogen that's produced purely from green sources, and that's where electrolysis is used to break water into oxygen and the hydrogen components. You may have heard of other types, blue or grey hydrogen, and that's where there's the energy input into the hydrogen formation is still reliant partially or fully on a fossil fuel source. So as there's a need in order to develop the energy transition to use both, so that it's still a lower cleaner fuel than just pure gas on itself. But yeah, what we're seeing is that there's a need to produce both the green and the blue hydrogen in order for us to, as a global sort of community, to reduce our overall greenhouse gas emissions. And then finally, sort of, I think in the energy transition, one of the largest areas where water is also required is mining, and that's getting the materials that you actually need to build all of the equipment. And one of the largest areas of that we're seeing is in lithium, which is critical for battery production. So you might be producing all of this electricity through solar or through hydro dams or wind turbines, but all of those are dependent on their sort of nature and how windy or how sunny it or how rainy it is. And it may be that one day you might produce too much wind, too much wind and electricity. So what we're needing to do is have a infrastructure to store that electricity so that it's not wasted. So you can make use of it on days where there's less wind, for example. Then that requires large battery storage. You might have heard of these gigafactories that we're looking to build in the United Kingdom that will to produce these batteries. And one of the key components is lithium in that. So and lithium most commonly is mined via a brine process. Brine is groundwater with the lithium in there, and so yeah, large part of the sort of water sort of supporting that to understand how much of that brine is actually available in the ground and how long it would be able to be extracted from, and the implications of taking it out on other people's water resources as well. So that's the sort of how we link into the energy transition sector, really. We are sort of the water side of things links into it, and it's a critical part of it, and gives us lots of interesting and varied projects. I think is the take-home point from this, so sort of from working in the UK across to the Middle East and wider parts of Europe. I think that's me quite quickly done. And so yes, hopefully there's some questions from people. I think it's sort of, like I say at the beginning, the careers in water is varied. So I think it'd be good to have some questions and curiosity about sort of where we might be able to go, or what careers we might be able to do and support.
Tom, that's fantastic. Thank you so much. Really, really informative talk, and lots in there about the different things that water is required for. Lots that I think people will find very, lots that people will find very new and probably didn't think about. You mentioned right at the start of your talk, you know, drinking a glass of water, and I just wonder, you know, just off the top of your head, just as an approximate, how many people do you think, how many jobs are there in getting that clean glass of water into your cup?
In terms of, like, there's a huge industry, and in terms of numbers of people working in the industry, there's obviously tens of thousands in the UK working with the water boards and things like that. But in terms of the number of actual jobs, like for people to do to basically do that, it's obviously dependent on where that glass of water comes from. But for an example, if you were to work in north of London, where the water comes from the groundwater, first of all you have your hydrologists. So a lot of the groundwater feeds into rivers, and it's critical that water has to be managed in a sustainable way. So if you were to pump groundwater, that could have an impact on the surface water, so rivers and streams and lakes and ponds. If you were to drain those features, that have a negative impact on the ecosystem. So your hydrologist would understand potentially the impacts that that change in the water balance might have. You have a hydrogeologist who would look at that water resource as well and be able to understand how long that water might be able to last if it was taken out at a particular rate, and also how that groundwater abstraction might impact on other users. Again, making sure it's sustainable. You're not overtaking more than you're really going to have without having any negative impacts. You've got your construction, your civil engineering, who will build the area around where that well will come, and then you've got those civil engineers, you've got sort of structural engineers, then you've got electrical engineers, mechanical engineers who will do the pumping and the piping, and you've got process engineers. Then you've also kind of coming up, you've then got chemists who will look at the water, and then you've got sort of people who then process it and put the filtration in and ensure that it all goes off. And then you've got storage of the water, and then distribution of the water along pipeworks in town to the towns and to then your tap. So yeah, probably that's just missing out about half of it. But to give you an idea, there's many different people sort of all supporting in that sort of way to get the water out.
Wow, that is absolutely fascinating. Thank you so much indeed. So going to your role then, and thinking about it on a day-to-day basis, what sort of thing takes up your time? Is there a lot of project management? Is there a lot of design? Is there a lot of interacting with the clients? What takes up your time on a day-to-day basis?
Yeah, I think probably there's definitely the technical components, which are the actual looking at the numbers and looking at the geology and that side, and then there's the sort of non-technical components, so talking to clients, doing the project management, which is equally as important as the technical bit. And I think you find that as you progress through your career, you might end up picking up more of the non-technical components, but it's all to support the whole part. So looking at a day today, I've just got back from holiday, so today's been catching up on quite a bit of updates on projects on where they are, but also reviewing technical reports is something we've got to get out today, and then also looking at the kind of understanding what's going on from some projects where we've done some investigations. So in order to answer a lot of the questions we're asked by our clients of like, is this going to have an impact on flooding, for example? So we're looking at a project where we're proposing to build something and we want to understand if that's going to have, that might lead to flooding. Obviously they wouldn't want that, so we look into it to find out if it is. And for that we do there's some testing, so we get a lot of data. We have to process all of that data, and then if necessary we may end up putting that data into a model to basically simulate what might happen if any changes were made to the current sort of situation, and then we'd use that model to sort of give us a better understanding of what might happen. So that's quite a large part, doing the technical part, and then yes, you have quite a lot of making sure you can explain to your client what you're seeing as well. And we find that probably about half of our clients are technically minded, so they kind of understand, they have come from the same backgrounds as us, so it's quite easy to sort of talk to them and say, yeah, this is happening, and this is why we need to do X, Y, Z. But then the other half they've come to us because they just don't know what the problems are or what they need to do, which is also quite sometimes very challenging to explain why you need to do certain things to people who aren't from that background, and that sort of make sure it's sort of that they realise what steps they need to do in order to achieve what their end goal is as well. So yeah, and then project management is also a major part, because as a consulting business we need to make sure that we're managing our projects and delivering them on time and on budget as well. So lots of numbers and making sure that you're forecasting and doing that side of things as well. I think we mostly do most of that for ourselves as well. So it's yeah, interesting side. Thanks.
Because as a consulting business, that means that people, well, organizations, clients are paying you to do work on their behalf. That's right, isn't it? Yeah.
So we work for sort of local companies or organisations such as the Manchester Science and Industry Museum, to global oil and gas or energy companies, and they come to us to be provided with a solution to their problems.
That's fantastic. And okay, you mentioned before about checking the environment, checking the impact that you're having on the environment and such like that. So do you get to go out and about? Do you get to leave the office to go to sites to investigate things?
Yes, yeah, we do, and that's probably one of the reasons I ended up coming into this industry. I'm quite enjoy traveling, enjoy being outside, and doing a 9-to-5 job in the office wasn't necessarily what I wanted to do. And through my degrees at university, we spent a lot of time out and about. I was lucky to go to Mexico, to the volcano there. Unfortunately, I didn't manage to get to Antarctica. It would have been great, but it's not very many tickets that way. So yeah, after university, where I was doing lots of outside stuff as part of my degree, it was definitely quite keen to make sure I worked in an industry that allowed me to continue being outside and to travel as well. And the picture on the slide at the bottom here, you can see is in Northwest Africa at a site where we were trying to understand what was happening with groundwater. So that was a long project there, and fortunately managed to also for work travel to North America, to Canada, to Georgia, to other parts of North Africa as well. And that's part of the reason I really enjoy my job, is for that travel, and also getting out and about. Obviously with COVID over the last few years, that's been restricted, but things have started returning a bit to normal again now with travel, because although you might be able to see quite a lot from Google Earth, actually getting hands-on and seeing the ground and the environment in person is critical. I think we've also meant to be going off to France at the end of this week for a project there. So yeah, there's definitely a lot of travel involved, and including even in the UK work. So where we're more sort of aligned to the infrastructure and construction side of things, there's obviously a large component of being out on the ground for that as well. That said, it kind of depends on your role. I know that some people are more keen to be office based, and we certainly sort of see a good mix of both people being out and about and people also being sort of based in an office with more sort of regular hours.
And well, that's sounds very exciting. You've been to lots of different places. Is Mexico your favorite place that you visited for work?
Oh yeah, so Mexico was for my undergraduate degree. I think my favorite country to visit was Georgia. Sort of just off the Black Sea, and that was in 2012, sorry, so quite a few years ago. Hopefully it stays a nice country. It was just very scenic, and the job we were doing made that we could go out across the mountains and things like that, and it's away from the cities. But yeah, it's not all lovely places. Part of our work is also doing brownfield sites where you work in redeveloping some of the areas that sort of need a bit of sort of improvement. In the UK, some sort of, I guess the Olympics was a good example of that, and working in sort of East London for a year and a half there, it was great. It was very interesting. We definitely saw the benefits of the improvements that were put in place by the Olympics. It was quite a rundown area of London, and actually by sort of improving the area there, you really saw that. So wasn't that nice at the beginning, but it definitely was good near the end. So.
Well, that's a really good point that you brought up there, which is that what you're doing makes a difference. You touched on the importance of we all need water, to drink, and you touched on the importance of it in moving to a greener economy. So does the fact that you are making changes, does that give you job satisfaction?
Yeah, definitely. So yeah, that's probably another reason to do what I do. In that, some of it's very functional, but a lot of it you're seeing improvements, either like large scale. So working in the green energy sector is obviously very rewarding, in knowing that you're actually making or supporting a way for our society to move away from their dependence on high carbon energy sources. So working out how or supporting that is very good, because you kind of feel that you're actually contributing to sort of reducing climate change, hopefully a little bit. It's not going to be one person doing that, but if we all do a little bit, then it should be a good thing. And then more locally, sort of within the UK, sort of more tangible stuff, I guess, that we can see on a day-to-day bit is part of our UK work is working on those brownfield sites that have had heavy industry in the past that are now derelict, or sort of not necessarily making the best use of that land. So that land's then cleaned up and is turned into suitable use, be it new accommodation or new business. And I think that's great, because you can see that like there. So I've worked on projects like the Olympics or projects in and around London where the sites have been derelict land and have now been transformed into suitable housing, low cost housing for people in need, which is not only good to produce housing, because we need lots of that, but also it means that we're making use of that land rather than letting it be derelict and using the sort of greenfield sites. So yeah, there's definitely a lot of reward from it from that point of view as well, for seeing a net benefit in what you're doing. And I think that's the sort of covered from energy transition there to housing. I think that's the kind of really important thing about working in water. It's not, it's so diverse, the sort of where you can go. And even if you decide to, like myself, to go for a specialist sort of subject like hydrogeology, even there, that still means you can link into lots of other parts. It's not just supplying water, it's how that water all links into many things. And I think probably a lot of the water industries can be so varied in which sector they provide, and the skills you learn in one sector is probably very transferable to another, which is good for a career development, but also being able to change with the times as industry changes.
Now, you touched on this in your talk, but you did a master's degree, which means that you were at university for 4 years. Is that right, for your job? But there are other routes in as well, such as apprenticeships. And I was just wondering if you could touch on a little bit about the differences between the different routes in, and what was your experience like as well?
So my experience probably more traditional for the hydrogeology side of things. So a lot of myself and my colleagues have studied at a university at an undergraduate level, and undergraduate doing normally geography, geology based subject, and then in undertaking that undergraduate degree have then identified an area that they want to specialize in, and the standard normally would then do a master's after that. So that'd be a 3-year undergraduate or 3 or 4 year undergraduate followed by a one year master's full time. I actually did my master's part-time, so I was working at the time of doing that. And fortunately, my company I worked with at the time was very keen that we took on that extra education. And so I did a part-time master's over 2 years, sort of reducing my workload down to 3 days a week whilst doing that. But that's quite, I think, probably the most common route for us to get into doing what I do. But then sort of more in the sort of construction side of things, there's a huge amount of apprenticeships at the moment, where you would, instead of going off to university, you sign up with a company after college, and then they would teach you on the job, and there's a program that you would follow, and you'd be sort of get sort of a you'd get the recognition at the end of the course with a diploma or similar qualification, depending on the apprenticeship that you undertook, and that's got many benefits. One, you are kind of working whilst doing the apprenticeship. And Worley take on a number of apprenticeships for our oil and gas business with process engineers. Slightly different to what I do, but we come in and then they work with the company, and then all of them seem to stay on and work with Worley after they've done their apprenticeship as well. So not only is it quite useful for your working and learning, you get to know the company that you're working for, get to understand their ways of working as well, and also that hopefully then leads on to a full-time job at the end of that as well. So it's a bit more structured and vocational to potentially the degree option. So yeah, so I think there's quite a few ways, definitely a few ways around getting into the business, and it sort of depends on what area you're interested in. But I wouldn't ever say there's no other. There's set ways into getting into any particular part of the business.
That's brilliant. Thank you so much, Tom. We don't have any more questions coming through, so I think we will finish it there. We're coming up to 2:20. So Tom, thank you so much for your time today. We really appreciate everything that you've talked about and the overview you have painted. So thank you so much for joining us.
Okay, yeah, no worries. Well, thanks everyone for joining, and I don't know if my details are shared via the site, but I'm sure you can get via Jamie if you've got any after questions that come up after the event. I'll be happy to respond to those if they do come in.
That's brilliant. Thank you ever so much. Thank you everybody for your attention today and for joining us. Don't forget, you can find out lots more about careers and options on the GMACS website, gmacs.co.uk. Thank you again for Tom for speaking to us today about careers in water for World Water Day. Thank you very much. We hope to see you again at another Meet Your Future session. Goodbye.